So in this video, I'm going to talk about how to rationalize the denominator. So we're going to be dealing with radicals, we're going to be dealing with fractions, kind of all wrapped into one. And what we kind of need to be aware of is that when it asks you to rationalize the denominator, what it's asking you to do is it's asking you to get rid of the radical that's in the denominator. If we have a radical that is in the denominator of our fraction, it is not considered simplified. And hopefully what we know about fractions is whether we're adding, subtracting, multiplying, dividing, really doesn't matter what we're doing with them. Fractions always need to be simplified in the end. If they can be simplified, you need to do so. So if you're ever left with a radical in your denominator, that's a for sure sign that's telling you, hey, this fraction is not simplified, there is work for you to do. So the way that we get rid of that radical in the denominator is we're going to multiply the entire fraction, numerator and denominator, by whatever that radical is. So for example, in A, we have 7 over the square roots of 7. It's the square roots of 7 that we want to get rid of. So we are going to multiply the numerator and the denominator by square root of 7 over square root of 7. Now keep in mind, we're technically here just multiplying by 1. Remember, any number over itself is just equal to 1, or anything over itself is equal to 1. So square root of 7 over square root of 7 is technically just a 1. Anything times 1 is that same thing. So this doesn't change the value of this fraction, but it is going to simplify it for us. Now we do need to carry out the multiplication. When it comes to fractions, remember that's straight across. Numerator times numerator, denominator times denominator. So 7 times square root of 7 is 7 square roots of 7. A number and a radical don't mix like that. In the denominator, we have square root of 7 times square root of 7. So there is a rule that deals with radicals that say if you multiply the same radical to itself, you are left with what's underneath the radical. So, for example, square root of 5 times square root of 5 would just be a 5. Now, you could technically multiply it together. Square root of 5 times square root of 5, yes, is the square root of 25. But the square root of 25 is equal to 5. So you get to 5 in the end, whether you're looking at it from the rule or you're actually calculating it out. But in our denominator, we have square root of 7 over square root of 7, which is just a 7, okay, using our rule here. So we got rid of the radical in the denominator, but we do need to make sure that there is nothing else going on in our fraction, that everything else has been simplified. Which in our example here, that's not the case, because we see that we have a 7 in the numerator, we have a 7 in the denominator. Those 7s can actually cancel. Again, same thing over the same thing, cancels to a 1. Excuse me. Leaving us with the square root of 7 as our final answer there. Okay. So for most of these here, all we're going to do is we're going to multiply the numerator and the denominator by whatever radical it is we're needing to get rid of, and then just work on simplifying it after that. In example B, we're trying to get rid of the square root of 5, so we would multiply by square root of 5 over square root of 5. Multiplying straight across in the numerator, 15 times square root of 5 is just a 15 times square root of 5. And then our denominator, square root of 5 times square root of 5 is a 5. Now the only thing we could possibly simplify in this fraction is the 15 over 5. Remember, 15 divided by 5 is a 3. Drop down the square root of 5 along with it. All right, since 5 was in a 15 3 times. So reduce the fraction, giving us 3 in the square root of 5 as our final answer there. Example C, we have the negative 5 over square root of 24. So we want to get rid of the square root of 24. So we are going to multiply numerator and denominator by it. In the numerator, negative 5 times the square root of 24 is negative 5 times the square root of 24. Over square root of 24 times the square root of 24 is a 24. We need to check to see if anything can simplify here. So we need to wrap up simplifying this. So there's actually 2 things that we need to look at with this example. Square root of 24 can actually be simplified. We couldn't simplify the square root of 5 or the square root of 7 because those numbers are prime. And there is no perfect square that goes inside of them or that would divide out from them. There is with 24, so that's a different story. I'll get to that in just a little bit. We can also look at our numbers, our 5 and 24, and see if those reduce regular way of reducing a fraction. 5 does not reduce with the 24 though, but the square root of 24, if you don't mind, I'm going to pull this out to the side. And remember, when you reduce or when you break down a radical, you can only break down a radical by using your perfect squares. Your perfect squares are 4, 9, 16, 25, 36, 49, so on. And we need to see is, can I use one of these numbers to break up 24? So thinking multiplication is 24 what times what, using one of these numbers. I only chose these 3 numbers because these are your 3 perfect squares that are smaller than a 24. Everything else would be too big. Now 16 times anything would never give you 24. 9 times anything does not give you 24. But 24 is 4 times 6. So I'm going to break up 24 into the square root of 4 times the square root of 6. The product rule for radicals says that I can do this. The one that's a perfect square, like the square root of 4, that is a2. The square root of 4 is 2, so we can break that down. Square root of 6 is not a perfect square, so we just drop that down. So what this means is, so I'm going to drop down the negative 5 and the 24 because we didn't do anything with that. But now we've said that the square root of 24 is the same thing as 2 times the square root of 6. This is what we got when we simplified it. So that means that we need to continue simplifying here. In the numerator, we have negative 5 times 2, which gives us a negative 10 square root of 6 over 24. And the only thing to do here is to simplify out our numbers. 10 and 24 reduced by a factor of 2. So if I divide out a 2 from there, I'm left with a negative 5 square root of 6 over 12 as my final answer there. So that one had a little bit more going on than the other 2 examples. So let's see how we're going to take care of D. So the first thing I notice when I'm looking at D, so we have a negative on the outside that needs to stay put for now. We're taking the square root of 7 over 50. So the quotient rule for radicals says that I can break this up between the numerator and the denominator and split those into 2 different radicals. So negative square root of 7 over 50 is the same thing as negative square root of 7 over the square root of 50, which means we do have a radical in our denominator, which means we are going to have to rationalize the denominator for this problem here, which means we're going to have to multiply by the square root of 50 over the square root of 50. Now in the numerator, we have a negative square root of 7 times square root of 50. That gives me a square root of 350 over the square root of 50 over the square root of 50. Square root of 50 times square root of 50 is 50. Now that 350 is a big number and that is going to be reduced. So let me see. So 25 is one of our perfect squares, and 350 happens to be 25 times 14. Now the square root of 25 is 5. Square root of 14 just drops down. What that means is my numerator here, that 350 is equal to 5 square roots of 14 over the 50 we have in our denominator. So we're almost done here, I promise. The only thing left to do is we need to simplify out the 5 and the 50. They can both reduce by a factor of 5. So that's going to mean 5 divided by 5 is 1, which means that goes away. So just drop down the negative and the square root of 14 over 50 divided by 5 is 10. This here would be our final answer for this problem. Otherwise, that's it for this video.